All right, so let's summarize now the role of sleep in memory processing. During the waking state, our brain is busy processing the complicated events of the world, and the EEG pattern reflects that there's complicated processing going on throughout the cortex. Now, meanwhile, the cortex is sending sensory information down to the hippocampus, where the convergence allows the hippocampus to, in a sense, bind those sensory aspects together to form an event memory, represented by a certain pattern of synaptic strengthening. So LTP will happen at greater magnitudes for important events compared to less important events, and that pattern of synaptic strengthening represents an important event. Now we're going to want to get that memory out of the hippocampus because there's a danger of synaptic saturation. If we continue to just learn and learn and learn, if we had prolonged periods of learning, we would get to a point where LTP was happening at all these synapses and no more LTP could happen. If LTP can't happen, you can't learn anything new because learning requires a strengthening of synapses. And this was the synaptic homeostasis hypothesis, that we're going to need to reset the synapses back to some baseline level so that new learning can occur. But before we do that, we have to get the memory out of the hippocampus, and that seems to be happening during slow wave sleep. Here we have the replay of the original experience. So we're replaying the memory in a way so that the memory can be moved to the cortex. Now, it seems that only those synapses that were involved in the most important events, they're the ones that get preferential sort of processing during slow wave sleep. And that's what we're calling system consolidation. Now, we also said that during slow wave sleep, of course, we're unconscious, and that was the result of the interruption of the normal communication between populations of cortical cells. This synchrony is imposed on the cortex by the brainstem systems. But notice now that serves a function with respect to memory processing, because when you're moving a memory from the hippocampal system to the cortex, you do not want any interference from what you're seeing or hearing or whatever's going on. Right, and so it makes complete sense that system consolidation should happen during a period of unconsciousness. That prevents interference during this movement of the memory. We wouldn't want new things that we're seeing or hearing or learning to interfere with the movement of a particular memory during system consolidation. And then during REM sleep here, we have yet another stage of memory processing. It's not system consolidation, but we'll call that either molecular or cellular or synaptic consolidation, occurring up in the cortex where the newly learned information is being integrated with previously learned stuff. And in addition, the bizarreness of our dreams can be understood in terms of these random signals coming up from the brainstem, and the cortex is, in a sense, sort of creating a narrative, often involving events that have recently happened. That makes sense, because after all, these new memories here, the newly consolidated memories, would be ready to be activated along with associated memories. And so some of the bizarreness of our dreams may reflect the fact that recently learned information is being integrated with other things that we've learned. Nevertheless, there's high emotionality, reduced agency. We don't seem to have control over the dream. For most of us, except the lucid dreamers, seem to have some of that capacity. But all in all, then, the REM stage is participating in a different aspect of memory processing. And it is here that we suggested that synapses overall are going to be weakened, both in the hippocampus and in the cortex, leaving behind only the strongest ones that represent the most important events so that they could be consolidated on another night. And the weakening of synapses is functional because that allows them to be ready to learn on a subsequent day. So sleep is the price we pay for plasticity when awake. And the reason we go unconscious during sleep is that sets up the ideal conditions for memory processing. We want to move memories without any interference from ongoing perceptions.